underside of the clouds. Just fabulous. So, well, thank you for that, Blair. I'm hoping everybody can see the screen okay. I thought I'd start by reminding everybody of what life used to be like. There's my badge from the World of Modular Convention that was held earlier this year, believe it or not. How times have changed. I will have met quite a few of you at that show. Not sure whether we're going to be able to have a in-person meetings by next March, by March of 2021, but hoping we can. So now we'll lay into this. So this slideshow covers the development of our new product, METALOQ. So we set some goals. I set some goals for the design process when I started this about a year ago. The goal, of course, as always, for me, is to enable successful modular construction, to address the challenges that people in the modular construction space have. And the techniques that I deploy are the same techniques in many cases that I've used since, you know, I started my company back in my first real company back in 1984, doing industrial prototyping for industrial design firms. So we deploy, first of all, textbook design for manufacturing and assembly, taught to me in the School of Industrial Design at the Ontario College of Art and Design back in the 80s. Since I became fully aware of the capabilities of the precision that CNC equipment can deliver, I've frequently and now always deploy attainable precision. Precision that is possible. I strongly believe in avoiding overreaching. So you want to deploy commodity materials and technologies, not something that's so leading edge that it will be, you know, tremendously difficult and time consuming to implement. I'm proud of the fact that for decades now, I've believed in zero waste or approaching zero waste, using the least possible material and process for every component. And using the least possible process is an important point. It's important in the modular space to make uptake easy with inherent simplicity. You can't impose on your customers something so complex that, again, they're going to have tremendous difficulty implementing it. And lastly, it's vital to share widely. If you don't end up with a large number of users of a given modular system, then you know, it's going nowhere for everybody concerned. There's a few things that have become truths, I think, subjects about which there's very little debate. One is that we all agree that a precision frame is a prerequisite for efficient modular construction, regardless of the scale. So whether you're going to stack a bunch of modules horizontally, stack a bunch of modules vertically, or do both, get that right there. There we are. You need precision is going to be valuable. And this is a wonderful, wonderful picture, presumably taken by a drone or from a nearby building of the Croydon project in the UK that went up about a year and a half ago now. I would say that this is the world leading project at this point. High material efficiency, rapid assembly, and in general, a very successful project that many of us are hoping to emulate in our work. So we chose steel. I certainly did actually consider wood very seriously, but we have chosen steel as the dominant material to work with. It's a whole nother debate, which you could get into at another time. So the first step in the process is to determine the most efficient shape and fabrication process for every element of a module frame. And a module frame, as we all know, consists of a shoebox-shaped volume that has an outline frame and infill material. Light steel frame buildings, especially panelized light steel frame buildings, are not dissimilar to that, or quite like that. You can see clearly in this image a blend of structural steel and light steel framing. Light steel frame buildings, you know, when the moments get big, when the loads get big, they rely on a very large number of point-loaded fasteners to connect the sheet metal elements together. And this can reach an extreme, as you see here. And by the way, you'll note that a large number of the fasteners, especially in the lower connection, horizontal connection there, you know, may or may not be engaging the member to which they're connected, because of the fact that that connection can be somewhat dodgy. Here we see a somewhat disastrous welding of galvanized to galvanized, including somebody beating a piece into place with a hammer to get a slightly improve the contact. You know, this is, you know, nobody, I think, would realistically claim that this is viable, you know, viable construction. So clearly, you know, this whole point-loaded approach to putting this light steel frame material together is going nowhere. You know, another approach is needed, and that's where we embarked on our journey. The central question that I asked myself at the very beginning is, could we eliminate most of the capital expenditure required in the development of the frame fabricating portion of a modular plant, and simply assemble module frames from a kit of parts? Is that realistic? And I believe we've demonstrated that that is the case by putting up this structure, which was completed just a few weeks ago. In this case, by the way, we painted the steel, so everybody's aware. It's not really necessary to paint the steel, but we did, and it looks terrific. And for tropical or other applications where the frame is exposed, you know, this could be a valuable approach. So how do we get here? This shows a computer model of a typical frame built with this technology, the METALOQ technology. Zooming in, you can see that there's essentially two categories of material here. One is cold formed sections, which, and by the way, there's a lot of variability in the use of these terms in the industry, but cold formed sections seem to generally refer to heavier gauge materials, let's say at least 1/8 or 3/16 up to 1/4 and even more. I'm talking inches here, by the way, folks. I apologize for that. We can have a conversation later in metric if you want. And then there'll be a horizontal system here made of light steel framing, which is typically considered to be material that's, you know, gauge thicknesses, so 11 gauge, 16 gauge, and so on, 18 gauge and 20 gauge. That is the horizontal system and the infill framing. I was taught by a great teacher of illustration, of technical illustration, back in the 80s, a fellow who now unfortunately has passed away. He did a lot of work actually on the manuals for the Avro Arrow and so on. So this is my sketching style, which is essentially a technical illustration style. This shows some of the early development sketches for the ideas that have become the METALOQ system. We quickly go to parasolid modeling in SolidWorks in our case, which is essentially CATIA. Here you see early views, analytical views of, you know, various potential approaches to the details of the system. You know, way back when I looked at the Powerwall system, which was developed actually in the UK, and at that time, this is already in the late 2000s, a number of people had realized that precision alignment features are key to the placement of modules with a crane. In other words, you don't want people to have to pry the modules into position with crowbars and so on, sledgehammers or whatever. You want it to drop into its location in the way that ocean freight containers do. So an essential prerequisite of a viable modular system is clearly a precision alignment feature. And this shows how ours works. We've opted to go to a downward facing pin, and I'll explain the reasons for that later. I believe, you know, I'm quite proud of the fact that we figured out that we could use those vertical locating fixtures as vertical tension connectors as well, and they can perform triple duty even as the hoisting connectors. So in one component or one family of components, we've been able to deliver three functions, further reducing the number of features on the module and further increasing the simplicity. We also, I determined early that we wanted a clamping connector. I've got a whole raft of sketches that show all kinds of dovetails various types of interlocking systems actuated by eccentric cranks and spiral this and that, some tapered everything. But it eventually evolved into this very simple component we call a dog bone, and it has tapered sides that exert a powerful clamping action as the connector is driven into place. So the sum of these components in the connection zone look like this. You have vertical locating and tension components, horizontal tension components, and supplementary tension bolting. And it all takes place within the base plate of the column. So there's no eccentricity to the load. But another major issue is how do you connect the light steel framing to the rim joist? So the common detail in this location is a sheet metal angle and a pile of tech screws. That sheet metal angle can be bent out of the rim joist or attached to the rim joist. We needed something much stronger than that. We recognized the value in the bracing action of the floor joist and in the creation of a torsion box floor. So I developed this detail. So we raise up a bead on the web of the floor joist, and we clamp that bead between a fixed clamp with a corresponding negative bead and a loose clamp with a corresponding positive bead. And that creates this 3-layer sandwich that grabs the web very tightly. Here you see the first of these features created in a hydraulic press in my workshop, in fact, in my garage. And by the way, the fellow in the picture here is Stephen Hailstrom, who has a company called the Modular Solution. Tremendous fellow who provided us with a great amount of assistance in the management of the prototyping process. So hats off to him for his help. Stephen, by the way, has delivered over 4 million square feet of modular buildings in a multi-decade career, and is one of the most accomplished people in Canada in this field, certainly in North America, in fact, in this field. Here we are you can see by the way, don't do this, don't follow our example. You can see our face shields in the background there. We're getting all sweaty in the middle of summer putting this prototype together and abandoning the necessary COVID caution. But yeah, here we are assembling the prototype of the first connection. And here's Stephen demonstrating that horizontal connection that you saw previously illustrated. So there is the first connection. This went very smoothly, went together really nicely. And so we proceeded directly to the 6-module construction. Next step, of course, step 4 in this process is the production design. I've got a long history in the development of these tools. Actually, at Walters Group, we did a number of these very nice decks, precision assembly fixtures. I'd done a lot of them previously for a variety of jobs. We did, for instance, 480 flights of handrail and guardrail in a Norman Foster Tower in Calgary using fixtures like this, and they're quite common, in fact, in the automotive industry. But we decided to build our own. Something that we took the leveraging of the CNC process to its logical extension, I would say. All of the locating features are machined from billet aluminum and billet steel. Anything that contacts a part that's being welded is aluminum, and this serves to dissipate the heat very rapidly and allows you to free the connection from the fixture sooner. So this shows that fixture in use in the factory in our low volume production setup. Here's inbound parts from the CNC machine and CNC brake forming. And here you see all of the columns for 6 modules queued with their kitted base plates ready to go into the fixture. And we did prove out the use of a cobot, which is an interesting category of robotics. On the production of these, we used the cobot to weld a bunch of the vertical stiffeners in to prove out the concept. We were readily able to program robot in minutes, interestingly. And these robots are not more, considerably less than 100 grand each. Very, very effective. And you can deploy, as many as 4 of these on a single fixture at a very modest cost and really churn these parts out. So we were very happy with the results of this portion of the experiment. This shows rim joists, all with their fixed clamps and welded to them and all ready to go. The fixed clamp has been designed so the welding is on the back face of the part on tabs, and consequently these parts are dead true, even with the welding of these parts. There's no significant warpage, no detectable warpage to these parts. This shows stacks of the I-span joist with the dimple. You can see over on the right hand the production, the so-called production, the manumatic stamping tooling. And here you see one of the first completed connections in the full-scale module frames. This shows the first of the hoisting connectors installed in a module base plate, upper base plate. This shows the first of the frames being assembled in the plant. We were fortunate to have a track crane with 2 hooks that could be synchronized or unsynchronized. So we used them in synchronized mode to hoist these. And we used the SolidWorks model to figure out the center of gravity of that upper beam. So we're hoisting it in a place that produces no deflection of that beam. And there's your first module completed with the crew that made up all the parts and did the work. And this shows that first group of modules with the material painted going together. The process was very quick. In fact, from the moment of arrival of the flat deck to a module being landed and the bolts in the vertical connectors installed, we got that down to 18 minutes on the last one. Here's a drone, a screen grab from the drone footage, which we're in the process of editing, showing the completed frame. By the way, since this picture was taken, we've taken out all the bracing in the front bays of the lowest level and in the front bays of the second level as well. So because a number of people said, oh my God, too many braces. So we were able to clearly demonstrate that of course the frames are viable with bracing only in some bays, not in all bays. Here's a close-up of the completed connection. Interestingly, I was asked if painting, would represent an issue, and I answered no, painting wouldn't be an issue. Sure enough, painting was an issue. The paint used this direct-to-metal, paint without primers, actually pretty heavy. And interestingly, we had to remove the paint from the ends of the base plates because the precision of this system is so high that the paint itself represented an issue. So it's important to note, so looking at this again, you can see that there's tight contact all across the top of the upper rim joist, bottom of the lower rim joist, and the base plates. And this is a load-bearing wall system. So this is not a point-loaded structure. And this, of course, allows a designer to put load into the wall panels or not, as the designer desires, and also to bolt the rim joist together if that's desirable to further increase the depth, the effective depth of the joist. So here you can see by putting a 10-inch joist and a 6-inch joist together, you end up with a 16-inch joist, which, as anybody knows, would be exceptionally stiff. This is kind of an interesting shot. When it was raining hard for the early part of the erection of these modules. You can see all the water here, and when a module dropped on another module, the water shot out horizontally from this gap. This shows one of the ironworkers just looking to see if the contact is tight. So some of the to delve into some of the features, just checking the time out, we're only 10:24, so we're doing good. There'll be lots of time for questions. This shows some of the features of the frame. There is the outer wall frame provides moment capacity. So it's quite a traditional moment frame. Anyone that's designed one of these would instantly recognize the stiffeners aligned with the webs of and flanges, in the appropriate fashion. But as you can appreciate, two of these 12-inch wide columns joined in this way function very much as a 24-inch wide member. And we found that jiggling this thing back and forth from the cherry picker at the top, while attempting to jiggle it back and forth, there was essentially no movement. So this is a very, very laterally stiff structure. You see here the completed floor system. One of the many features that I sought to deliver is ease of fastening all of the board that has to be fastened to a structure to make a complete module. We've fastened mega board, magnesium oxide board, fiber reinforced magnesium oxide board to these floors. And of course, putting the self-drilling, self-tapping fasteners into the edges of the eye span is easy. You see also the rim joist. You may be able to see on your screen the holes that are already supplied there all the way around all of the openings to allow for the easy installation of the infill framing and the floorboard and the tying in of the floorboard to the rim joists. So and because the rim joists are essentially a C-section, you can reuse a right angle drill to pop holes up through these pre-drilled holes through your decking, through your channel, and thereby create a sandwich of the channel that's at the base of the wall assemblies, the track as it's called in the sheet metal stud industry. So you can make a sandwich of the track, the floorboard, and the rim joist by slipping in some 1/4-inch fasteners. And here you see the iron worker putting in the last connector. For many of you may know this story, but I think it's worth mentioning here that Walters is one of the largest employers, has been for many years, the largest employer of iron workers. And many of the iron workers in our part of the world are native people. This fellow is, and he's proudly wearing his poppy there, which in Canada is a popular symbol of Remembrance Day, which is tomorrow. So we've got some good symbolism hidden in this image here, and some good honorable traditions here. So this I think is the tail of the tape, the money shot here. We're at the top of level 3, the connector that fellow has just installed, and you can see that the base plates are perfectly flush at level 3. You can see they're in perfect tight contact at level 3. And so this is the extent of the tolerance accumulation at this point, which is 0. Couldn't get a business card anywhere in here. So we're holding something under 10 thou in terms of vertical tolerance accumulation. It's an imperceptible amount, essentially. It's actually interestingly less than the thickness of the paint. So the bottom line here is we've developed a kit of parts that can be shipped as skidded components. They can be assembled in a few hours on a flat floor by a small crew with handheld power tools. We used cordless drills with sockets on them. So what this points out is that the setup cost for METALOQ kit frame users is negligible. These things drop into your plant, and with $400 worth of labor at $50 an hour, fully burdened, you got a frame. Of course, such a concept wouldn't be complete without the IKEA instructions. Very easy to generate out of the computer model. By the way, all the parts are etched with part numbers so that they're readily identifiable in the assembly process. And we're further rationalizing that, actually, interestingly, by putting little diagrams on some of the parts to clearly show their orientation. So now I'm sorry to say we get into some of these Julian reads text type of slides, but hopefully nobody's falling asleep yet. So some key features of the METALOQ modules are, first group, These are industry standard deliverables: top pick, structural, precision, high stiffness, flush top and bottom faces for load-bearing wall applications. By the way, interestingly, the flat top to the modules confers a big benefit in the in-process waterproofing. So, you know, if you have to stop work on a Friday and you're expecting it to rain, or it's already started to rain, you can roll out tarps over the top face of this and there's nothing to interfere with those tarps. The top face of these modules is perfectly flat. There's also nothing to trip on. It's an all bolted assembly in 2 hours with wrenches or impact drivers. Interestingly, what does that mean practically? It means your plant doesn't require any certifications for welding or any of that stuff. You know, obviously you have to have QC procedures to ensure that the fasteners are torqued to the right values and so on. The use of light steel framing and floor and ceiling joists makes the MEP circulation dead easy, makes the board fastening with self-drilling, self-tapping screws fast and easy. And, don't know what that and is doing there. The vertical connectors are triple purpose. They provide hoisting, locating, and tension capacity in one component. This hybrid structure, and I use the term hybrid to mean a combination of light steel framing and cold form steel with this strong horizontal connection, delivers diaphragm action and allows braced bays. So you can take loads through the floors to an elevator core, stair tower, hallway, you know, the walls in a hallway and so on, where you have, you know, continuous vertical bracing. Light steel framing, this light steel framing concept, this is going to start to get pretty interesting in the next couple of slides here. We're hitting 12.5 pounds a square foot on these structures. We've engineered up to, you know, as you'll see, up to, you know, more than 10 floors, and we're still, you know, well under 20 pounds a square foot. And the configuration of the 2x4 ceiling joists and the 2x10 floor joists, which in this case, in this prototype are I-span, is very similar to UL H501, the standard that was developed by United States Gypsum, and many other similar standards. So we believe the path to acceptance from a fire viewpoint is very straightforward. How high can you go? What does a typical frame weigh? A little more detail on that. So the engineering diagram that you see on the left there, this is a frame where none of the material in that frame, which is a tall and narrow building, so it's only 2 wide, it's a 2x2 footprint, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 stories high. And you can just see we're getting a couple of diagonals in the lowest level that are reaching 100% of their load-bearing capacity. So what that's telling you is that A, dead easy to upgrade those members, B, all of the other members in this 10-story structure, which is, by the way, being shown here in Florida wind conditions, are overbuilt for their role. So we could in fact take weight out of these. So, you know, we're as we put it colloquially, delivering a lot of blue. There's a lot of excess capacity here, even at 12 pounds a square foot. You know, 12, 13 pounds a square foot. So now, perhaps the most exciting part of this. So, you know, I hope that you're convinced that the frame is viable and that it's usable. We're continuing to work on a number of you know, leading edge products that will augment users' ability to make use of this system. So number one of these is to leverage the precision in the connection zone, is to introduce self-mating MEP connections. So just like, you know, the garden hose fittings that you can buy that snap together, or air fittings that are common in manufacturers' plants, there are fittings available off the shelf that would allow both the hot and cold water to be joined with self-aligning connectors as the modules are set. And electrical connections are actually even easier. There's a number of systems available off the shelf that have been developed for the modular data center industry and various military applications that allow both data and power to be connected with self-aligning connectors. So, here you see a down-facing view. So what's interesting about this is, as soon as a module that is set is inherently powered, or you have power on board via a battery pack, we can actually have actuators in the module that perform the locking function at the point that the module is set. So if you can imagine eliminating the need for the workers on the roof of a building to go out and make the initial connection that allows the crane to leave and go back and get another module, and in low-rise applications actually provides adequate capacity. That is, revolutionary in terms of cost. And interestingly, these actuators are non-expensive. We've sourced a number of them. One of the most interesting was designed for chairs, for the elderly, standing chairs that stand up. And they're, something in the order of $30. They have a 10,000 duty cycle rating, and they have 900 pounds of thrust. So on a tapered pin, that's more than enough for a 6-story building. And then this is the inevitable consequence, of course, of that, or where we're headed. Once you have power in the modules, and once you have these locking features available, we can deploy a live module which can be hoisted and placed with a drone halo, which we are in the process of developing. So if you can picture, what are the consequences of that? I think I'll skip. Actually, no, you know what? That's a slide I've eliminated. The consequences of that, of course, are that the crane operator can assemble the building, essentially. That's likely an exaggeration. I think that people still will be required for the near future, but a very great proportion of the work that formerly required large teams of people, I think, can be eliminated, together with all of the safety issues that arise when you have people working at heights. So Blair actually was instrumental in developing the Simply Precise tagline. We think it's really, I like it a lot. What does Simply Precise really mean? It means that for modular builders, a turnkey business solution that supports expansion with minimal capex. So it's simple, it's precise, you get all of that, and simple in this case means inexpensive. For developers, it's an alternative delivery method built on accountability and collaboration. Build correctly, predictably, faster. That's simple and precise. In this case, the financial modeling is precise. The timeline is precise. For steel fabricators, it's an opportunity to diversify from feast or famine commodity work to something proprietary manufacturing and a predictable deal flow. For architects, a balance between creativity and efficiency. That's a difficult balance to strike, and I strongly feel that we're in a position to support architects in that goal. And for society at large, a solution to the housing crisis, all of the dependability and cost and so on are all essential to being able to deliver the housing that's so desperately needed. And here I think is maybe the biggest news. This will be the first time that almost anybody has heard this. We're in a position actually to start shipping kits from our low volume production setup at Walters, and they have established pricing at 11K. That should be USD, US dollars. I apologize for not putting that in there. Prices start at 11K FOB for a 382.5 square foot frame. That's your kind of classic 13.6 by 28 with a 9-foot inside ceiling height. If you infill some portion of the walls, of the wall voids with framing, you lose some of that square footage. If they were all filled in, it would drop to about 350 square feet. And there you go. That's there's your contact information. Obviously, this is dead easy to get off our website. We're in Toronto, Canada, so for those of you in Europe or Asia, we're in GMT -5, which can vary because we're still doing that daylight savings thing. So it can be GMT -4 at times if we're out of sync with other jurisdictions. So thank you for that. Thank you for your attention to that. It's 10:40. As Blair said at the outset, we've got lots of time for questions.
Well, let me suggest we run a couple polls because we'd be interested in hearing what you have to say about, you know, what you're doing. And then I do have some questions for Julian to answer. Julian, if you want to look at the question bar, you can see the questions. But let me launch these polls, and if you guys could vote quickly on that, that would help us understand a little bit of the space, and I'll share the answers in a moment. And please also ask any questions you'd like to ask on the question bar. So if you could just quickly vote, that would be great. I'll stop when it's about 75, 80%, and we're ramming, get there fast here. That's great. Couple more, please. Okay, that's good. So I'll share that with you. So about half and half, which is interesting. Which is, you know, this is great because there's lots of opportunity here for those who have done it before, and obviously some really interesting opportunity for those who have not. Let me ask you one more question, because this is more for the people that that have done it. What kind of frame system did you use? So for the half of you that did use a volumetric modular, please answer that question. So I suspect that's going to hit around 50%. So just wait a few more votes, and then we'll get to the questions. Okay, and interesting there too. It's we have democracy, 50-50. We have been thinking and would love to engage with a wood modular company because this could open up a big door for them. They could easily buy METALOQ frames, put them together, and drop them in just after their wood assembly line and fit them out, getting them the chance to go after non-combustible construction and taller buildings. So it would be a great business expansion opportunity. And we would love to work with a wood modular company who's interested in doing that and engage all the details that it would take to make that happen. So thanks for your votes, and I'll turn that off. And Julian, can you see the questions, or should I just go through them?
I'm struggling to figure out where to see the questions.
Okay, I'm the guy who's used
it. Seems like you and I should have practiced this.
That's okay. I know I didn't look like I did in the beginning, but I know how to use the tool. So how is your system fireproof for types 1 and 2 construction?
So the, you know, this isn't, what's interesting about this is that it isn't weird. You know, the floor joists are light steel framing, the ceiling joists, light steel framing, the wall studs would be light steel framing. So all of the details that are common to that industry apply here. So, you know, when you think about the number of buildings that are going up using products like SureSpan and iSpan, you know, conventional Bailey, as we call them here in Canada, or Clark Dietrich in the US, you know, all of those details are common to this type of construction. So the difference lies in that wall studs, you know, you have one set on one side of the mate line and another set on the other side of the mate line, where you have a partition between two adjacent isolated spaces. And so they're in, you know, depending on the jurisdiction, people can require the installation of some sort of fire caulking or, you know, foam tape or whatever in those areas. But the fireproofing details are not in any way bizarre here. We do obviously from this point have to develop case-specific fire details for this product, and in some jurisdictions there may be approvals required. In other jurisdictions, a letter of conformance from somebody, you know, from a consultant in that field may be enough to allow us to build. So yeah, but you know, do we have work to do there? Yes, but is it insurmountably different from prior approaches? The answer is no. By the way, anybody that wants to can visit the iSpan website and look at the many details that are being deployed on a daily basis there in terms of fire stopping and fireproofing, and they'll immediately see how applicable it is. You can also look at the UL and ULC sites and see the very many details there that are you know, specific to light steel frame construction.
And the next one is, do you have any ICC/ESR reports?
International Code Commission, I think, or consultant. We have no such things at this point. This is early going.
And we'd be happy to work with somebody on that.
Yeah, good point. With this now being public, we're absolutely looking for industry partners, you know, other than the usual suspects that we can work with. We're currently entertaining, we're currently engaged in negotiations with a couple of university-led centers of research into modular construction, with the intention of partnering with one of them in order to do the work that the past two questions have alluded to. And in addition, of course, full-scale destructive testing of all of the connections and so on.
But just to make it plainly clear, you saw where we are. We are looking for partners to grow this, and we'd be happy to engage your interest. Next question is this system designed for drywall, electrical, interior finishes, etc., to be completed in the factory setting, or only a structural assembly? I think the answer is yes and yes, but I'll let you answer that.
Yeah, you're absolutely right. Yes and yes. So certainly the ease of application of those of the board, the floorboard, wall board, ceiling board has been delivered with all of the holes and the light steel framing and so on. The rigidity of the system is certainly adequate to allow you to complete these modules in a factory, hoist them, put them on a truck, take them to a site, hoist them and place them on the building. That is the primary delivery method that we're supporting here, is full volumetric modular construction with high completion in the factory. But a number of people have pointed out to us that what you see what you've seen is certainly a great way to deliver tens of thousands of square feet of space in days that could then be fit out at the site. So we're actually calling that phase zero. I can't remember where that came from, but that's the phase zero approach. But this is a volumetric modular construction system intended primarily for factory completion. But by the way, as to that, let me point out one thing. At each of the ends of this module, there are 4 perfectly sharp outside corners. And so the location of facade panels and so on these modules, and knowing where they are in 3-dimensional space is particularly easy. It's the easiest system I think that has been developed by anybody so far. It has been a challenge to place panels on the ends of modules such that the space around the panel is very, very perfectly defined so that the facades can conceal as the modules are being placed. And we believe that this solution makes that whole process a lot easier. So the idea of completing a module, including its facade, is something that I believe in, and I think we've achieved it.
What are the limits on width and length?
The only limits are practical in terms of shipping. So with this that you see here is 13.6. The 9.5-inch I-span joist, I think with the bracing package and so on, goes out to about 16 feet, something like that. And then you'd have to increase the depth of the floor, which, given that all these parts come out of computer programs, there's no hard tooling in them, is something that isn't particularly difficult to do. So if one wanted to ship module, if one could ship modules that were 20 feet or 25 feet wide, you could. Longer, again, not challenging this very deep truss concept. These modules were at just under 30 feet long, were extraordinarily stiff in the long axis. So increasing the length of them wouldn't be challenging. Increasing height, again, it's just a question of shipping. Shipping challenges. So really, the limits on the dimensions are practical.
And a business aspect too, because there's going to be a business decision on how many designs and how many sets of shop drawings, but et cetera. But our system is a SolidWorks model. So technically speaking, we can do just about anything. Business wise, if we have a 350 square foot module and somebody comes and asks us for a 352 square foot model, it's probably going to have some pretty good business case that the 2 extra feet makes any sense. So
yeah,
design for manufacturability, manufacturing and assembly set, principles say, have the right module and then design around it.
Yeah, I agree with that. I mean, a significant source of issues for a number of modular companies has been the projects where there's an excessive number of variants in the modules, and that just leads to extraordinary design costs, project management costs, assembly costs, and so on. and it certainly seems like something to be avoided. The most successful modular deployments, certainly in North America and I think around the world, have been deployments where there's a relatively high degree of uniformity in the modules.
Next one I'll answer is Walters, the exclusive fabricator. So we've signed with Walters to be our exclusive fabricator for Canada, and we are investigating the opportunity to use them in other places, but also entertaining dialogue around other fabricators. The overall model would be several fabricators, but not a whole lot, because that's where the tooling and design investments are. It's not a very complicated product, but that is where the tooling and design aspects would be invested upon. And then there'll be a lot of modular builders who could leverage those designs for their business. So if you are one of those steel fabricators, then give us a buzz. One of your friends has left, Julian, but he says that's terrific. So thank you for the compliment. And the last question we got here, maybe it's not the last, you can keep asking questions. Yeah, it's not the last. How many projects have been completed to date? And I'll answer that too. None, except for the system that you see in front of you, and what we have done, and with great leadership from Julian, gone from 8 months from concept to design to patent filing to prototype, and production. We'll have low volume production offering. We'll probably announce that tomorrow. And the barriers to entry to get through all that were not very high. The funny story is when we sat there watching it come together, we're like, is this all there is? Because it really did come together very, very well. And that's the hats off to Julian and his thinking. The other reason, and one of the reasons that encouraged me to be part of this, having launched lots of products and processes in several different industries, is that the various players in the supply chain really do what they already know how to do. So the barriers to entry for an architect to take a modular design, a Revit from our SolidWorks is straightforward. The steel fabricators would take shop drawings out of our SolidWorks, so a CNC machine would be directly driven off of our model. and then a modular builder would get these modules and basically bolt them together, and they would know that they're perfect, but they also would get the shop drawings from our model, and then the fellow hoisting it in place would do what they already know how to do, and we also have innovations coming to make that even easier. And then on the job site, one of the biggest challenges is modules not being precise, and therefore when they get to site, they don't match the foundation. We wouldn't be the problem. The modules are going to be perfect. Yes, the foundation needs to be where it should be, but there isn't going to be a mismatch if both participants do their job. So we think it's ready. There are some other things that need to be done, some destructive testing, some to get some fire equivalencies, probably some building departments buy into it, things like that, but there's really no technical, structural engineering, product development aspects that are going to limit us from being in a building. Would you have any more comments on that, Julian?
No, that was good.
Then thoughts on HVAC systems and ducting?
Actually, this shot is a good one actually for discussing that. So you can see the floor joists have these, these generous openings in them. I-span, interestingly, facilitates, because it has this doubled flange top and bottom. So let me see if I can find a shot that really shows. Yeah, there you see the I-span. If you look down at the bottom corner of the picture there, you can see that the top and bottom flanges of these I-span members, the materials actually, the steel is actually rolled over double and then taken down, and then there's another secondary flange, and that's all hemmed together. So as Walter Kopelar liked to say, the steel's where it ought to be, which is as far away from the neutral axis as you can get it. And so there's a tremendous amount of strength both above and below the openings in the joist, and the openings are flanged. So you get a good generous opening. These in the 9.5 inch, you've got a 5 1/4 inch ob-round hole here, which is adequate for quite a bit of circulation. Obviously, any drain pipes and so on. So MEP circulation through the floor and ceiling is pretty easy. At the wall, we make the rim joists are a little bit narrower than the track of the ceiling of the wall, and so there's an opportunity there to pass material between the walls and ceilings. So it's relatively straightforward. Modular building designers have to, are faced with that perennial question. Do we take everything out to the hall and then go through the hallway ceiling, or do we drop everything through a continuous riser? And that's a decision for the mechanical design team and the modular design team to address. If I missed something, if the questioner, if the person asking the question has a specific question that I didn't cover, please do ask it.
So somebody mentioned that I didn't allow multiple answers to what type of material did you use. So we still have everybody attending, so I'm gonna launch that poll again. And so you're able to click both boxes if you so desire. I think that's worth capturing that information and sharing it with everybody. So if you...
This is an interesting debate, the wood versus steel debate. I tend to think that, this may be heresy, but I do think there's a role for wood, I mean, people in the steel frame modular industry would maybe dispute that, but I don't see wood framing as as the enemy or something that needs to go away. They're in fact complementary technologies. I do think that with the wildfires that have been happening and so on, that there's people ought to look hard at putting wood buildings with vinyl or aluminum siding in places where fire is likely. But
so I didn't create a box saying both, but we still see this sort of 50-50 answer. What I'd be able to do is get the answers of who clicked both. And I'll publish this kind of information on our website. I think it's really worth sharing to the industry. So
Nice.
Let me go to the next question. Have a couple questions. What is the height limit? How is approval processed by the city? Can we have cost per square foot?
So the height, so that's a good, all excellent questions. So that was height limit, cost per square foot, and what was the last one about the city?
Processed by the city. Approval process.
Approval process, okay. So height limit, you know, it's easy to say there's no practical height limit, you know, beyond, you know, super tall. So one can build, you know, a structure somewhat unlike a filing cabinet and put the stacks of modules into the drawers. So you could have, you know, a mega frame made of heavy structural steel. It could have a floor, a transfer structure at every, you know, 20 floors, and you put a 20-story stack of modules, then a transfer, 20 floor stack of modules, and a transfer, and so on. You know, that's certainly a possibility. That's something that, you know, construction cost professionals, you know, are capable of figuring out what makes sense. Certainly, the frame as we configured it with the material thicknesses that we used in the prototype that we've built is good to 12 floors in accordance with the engineering we've done. That'd be 2 stories of podium typically, and then 10 stories of modules. That can definitely be stretched to 20 stories by augmenting the bracing and the wall thickness of the various materials and so on. You know, it remains to be seen where the sweet spot in terms of cost lies there. So that's number one. Number two, the weight, was the question weight per square foot or cost per square foot?
Cost.
Cost. So at $11 US, 11,000 US dollars for a 382 square foot frame. Let me think here. We'll do the math. 11,000 divided by 382 it's $28 a square foot. Fact is that, you know, the $11,000 price per module frame kit is based on our low volume tooling. We expect as volumes go up, that price to improve, to drop. How much it drops will very much depend on the number of these kits that we make and the investment that our manufacturing partners make in equipment and tooling to produce these kits. But you know, that is already, I think, a highly competitive number, very competitive number for a hoistable volumetric frame. And we're very grateful to Walters for being willing to introduce the frames at that number. That's you know, we think it's tremendous. So as far as the city's approval process is concerned, you know, as everybody knows, unfortunately, in North America, it's highly variable from jurisdiction to jurisdiction. Until recently, there were jurisdictions in North America where you didn't even need a building permit to put up a building. There are, I think, some rural jurisdictions that are still like that. In other jurisdictions, the standards are extremely tight. Places like Chicago and New York, you know, in some cases they require even 3-hour separations and so on. And the West Coast, you have seismic considerations and so on. So the process can vary dramatically from jurisdiction to jurisdiction. It is possible to design a building, to have an engineer design a building frame, stamp the drawing, and have a building official accept that. It is possible to have engineers who specialize in fire compartmentalization, fire protection, design a frame and put a stamp on it, and that will be accepted by building officials. There are other jurisdictions where you have to have the entire, you know, the international jurisdictions where you have to have the entire system approved, which can require full-scale testing or scale testing for seismic performance and so on. So, you know, the route to approval by authorities having jurisdiction is, you know, there's many different routes. And we freely acknowledge that there, you know, that we have much work to do in that area, and consequently, we're looking for partners who are, who see the value in what we've done so far and are willing to undertake the further steps that are necessary to gain broader acceptance and broader use of the product.
And I can answer this. What is the relationship between VECTORMINIMA and the engineer of record? So Intuitive did all our engineering to this point, which led to our ability to build the frames the way they are and to file our patents. And basically, we have enough of a model that another engineer for another region could take that information and understand it and stamp drawings. Fundamentally, it's structural steel, nothing really special. And the load design is actually more about hoisting it into place. Therefore, it's pretty much over-designed for the actual building. So in essence, if you had a project in Texas and you had a local structural engineer, we could engage them with the work that was done by Intuitive, and they could stamp the drawings. Pretty straightforward. Let me just say, you mentioned that the MO board had a similar rating to H501. I have heard certain MO boards have not updated their certifications. In addition, there is a report circulating that there is a chemical seepage that corrodes metal. Any comment?
Yes, we're well aware of that. So, the magnesium oxide board is not actually a terrifically new product. It's been around for quite a while. And there certainly has been some magnesium oxide board produced that that had excess, I think it's chloride or somehow free chloride. And so in the presence of moisture, that chloride could attack the portion of the fastener that goes through the board and corrode it to the point there it would actually break. So that there's no question that the person asking this question is correct, that such board was made and that problem did occur. So, but as it is today, there have been, millions and millions of square feet of buildings produced using magnesium oxide board, and such board has been left exposed to the weather for extended periods of time during construction. And the claims that are made by the board manufacturer that the chloride, the free chloride or the reactive chloride is not present have been demonstrated to be correct in actual service. To be clear, we use magnesium oxide board in this case because we really like the product. It has a dramatically higher fastener pull-through strength than some of these fiber reinforced cementitious products. But if you do have a concern about it, you certainly have many alternatives, not the least of which is the United States Gypsum's product, Structocrete, which is also extensively used. So I would say, if you are unable to satisfy your concern regarding the magnesium oxide boards, despite their lower cost and superior performance, then the Structocrete or the boards like it are a good choice. Further, it's also possible to put decking in our modules and cast concrete on them. So one can create a composite concrete floor in a METALOQ module. And by the way, that's the practice of Vision Tide in the UK, a very successful company. Sorry about that, my phone's ringing. I didn't turn it off. Their modules, as I understand it, have concrete floors. For years, Deluxe in Berwick, Pennsylvania, have been making modules with concrete floors. So, and I believe Capsis in the Brooklyn Navy Yards, the much lamented former Capsis, which was a terrific company, also did concrete floors. So, and we support that approach as well. So there's a variety of ways of putting a floor into these things.
There's a lot more questions, so we'll keep going as long as there's questions. The recording will be on our website, and we'll put all the questions and their answers, if they're not already answered, on our website in the Q&A portion. So what is used for wall studs, steel or wood? We designed it with steel. The cross bracing where it is needed would go through holes in the steel, which would automatically be perforated using like a frame CAD system. Wood isn't out of the question. We had the question yesterday when we were on a job site, or actually, sorry, in a web meeting with a client. We would have to be designed, but the wall studs themselves are not structural to the system. They're just infill panels. You already answered the question about concrete. Here's a wild, interesting one. Can circular buildings be facilitated?
It's funny, this one always comes up. So, of course, yeah, you can certainly make these module frames. You can certainly articulate these components so they would make a trapezoidal module, like a conic module, and those could be assembled to form a circle. The angle on the connections obviously determines the radius of the circle. So if the angle is small, it's going to be a large radius. If the angle is large, it's going to be a small radius, and so on. If there was some compelling reason to do that, we would certainly consider, producing those modules that made circular buildings. The answer is yes, but the volume has to be there to justify the unique tooling and engineering. There are a number of structural advantages, interestingly, to round buildings, circular buildings, but there are disadvantages in terms of material utilization. So especially if you are using board decking and board on the ceilings in particular, there is an increase in material loss, but it can be minimized using nesting software. So there are ways to get around that. So the answer is yes, if there's a business case for it.
How are the wall studs attached? And I think the image that you have up right now is really good, because on the left-hand side, you can see a little hole there, and our beams and our columns would be pre-drilled with holes that therefore a fastener could be put through from the studs through to the structural steel. You want to make that one answer that more than I just did?
Yeah, that's absolutely correct. The upper edge of the lower rim joist and the lower edge of the upper rim joist have rows of holes. I believe they're at 8-inch centers, if I'm not mistaken, and therefore attaching the track in the horizontal planes, and the columns likewise have holes in their vertical edges for attaching the last stud in an infill wall panel.
And then the next is on the interior modular mate wall, can the cross bracing be removed or modified if the plan requires an area wider than one modular? And the answer is yes. What you're seeing in our mock-up is we put cross bracing everywhere because we wanted to have it all the same, and we wanted to see how the modules performed when we hoisted them. Seeing that those cross bracing are so thin, if they went into compression, we would know right away. They did not, which obviously meant our design to have all the cross bracing in tension worked. We weren't surprised, but that's why we did it. Now, the first thing we did is we started removing cross bracing so everybody could walk around the module. And if you were doing a real building, a structural engineer could decide where the cross bracing should be. And obviously you could have a 2-unit or a 3-unit, 3-module unit to make 1, 2, and 3 bedroom and it's just a little bit of engineering to decide where columns and cross bracing need to go. And then that's longitudinal cross bracing, and then the transverse cross bracing is inherent to the design, so there is no need for cross bracing the other way, and therefore the facade, for example, on the one end of the module could be window wall encompassing the entire frame. So that's a little bit of answer on cross bracing.
Yeah, I'm just putting an image on screen here that shows very clearly the bracing removal. So you can see here on the ground floor, we've taken the bracing out of all of the front bays. And on the second level, we've taken all the bracing out of all of the side bays on one end to demonstrate the concept. And this, interestingly, this didn't impair the structure of this module at all. It had no perceptible impact on the stiffness of the thing in the vertical dimension.
And
So
the other thing is the floor causes a diaphragm. So when you see some cool video we're going to have on our website shortly, you'll see some yellow bracing horizontally. And that's what we had to put in on the second and third floor because we didn't put a floorboard up there and use a diaphragm. The other question was, can you remove the cross bracing when you get to the job site in case you didn't need it? Obviously, yes. I mean, it's a be straightforward thing. There'd also be a number of technologies one could use for cross bracing. You don't just have to have these these X crossing systems that you have, and we'll probably come out with more design ideas on how to do that over time.
Yeah, I could supplement that answer by saying we know that we have a lot of application-specific engineering and design to engage in. So we're fully expecting that customers will contact us and discuss projects, and we will talk about how to address the specifics of those projects.
So Julian, our price should go up because it says here $11K for a knockdown 383 square foot frame seems reasonable. That's too bad. Rough idea how much to erect a single frame for an all-in dollar amount for a single standalone frame, maybe hours to build a single frame.
Good.
Do you want to answer that?
Excellent questions. Yeah. So we were readily able to assemble these frames after, actually, interestingly, our first one went together in 3 hours. The second one went together in 4 hours because we were getting smarter. No, wait a minute, but the last one went together in just slightly under 2 hours. So, and our prediction, we did do some time motion kind of thought on this, and so our feeling is that a safe rate of assembly with a modest crew, say 4 people and maybe 1 forklift operator, crane operator, is 4 hours. Is 2 hours, which is rough something like 8 person hours. And if you use a figure of $50 an hour, which is a high figure really for burden labor, you're coming up with say $400 to assemble the frame is the cost to assemble the frame. Then as far as placing the frame, as everybody knows, there's a lot of costs, a lot of variability in those costs. A lot depends on how far the site is from the plant where the modules are fit out and so on. But certainly, you can do the math on mileage for the trucking, crane time, crew time, and so on. We believe strongly that the number of such people needed to deal with these frames is lower than the industry average. The precision helps. Our connection systems are straightforward. I think that will help a lot. And there you go.
So the next one, identify if you received UL, ULC rated assemblies. Has the system received BMEC and BCC certifications in Ontario? Officials always look to read to rated assembly numbers and test results. What are the size limitations of the module? So the sizes, I think we answered.
Yeah, we discussed size earlier. No practical. The limitations on size are practical and related to shipping constraints. And no, we have no certifications from anybody at this point. But we believe that we have a straightforward path to attaining such certifications because the assemblies are not so bizarre that they're, cannot be understood by the authorities having jurisdiction. So it is the I-span floor joists and the sheet metal stud ceiling joists and wall studding are common. The connections are clearly superior to the connections normally deployed between the joists and the rim joists, and the rim joists are of a scale and material dimensions that are not uncommon either. So we don't foresee huge challenges there.
And I've had, people can discuss this all day long, but I've had BMEC and CCMC exposure because I'm involved with the facade business, and what they're there for is to evaluate products that are really outside of the building code, and maybe they perform the purposes of the building code but in a different way. And the example brought to my attention by a building code expert was like waterless toilets, which fit the building code on a purpose but do it in a completely different way. Eventually the building code catches up, but in our case, we're really doing construction the way construction is done, because at the end of the day, we have more steel, we have the same kind of structural elements, we have the same loads passing down through the same kinds of materials that would normally be done. So I doubt we have to go down the road of the BMEC or CCMC. They're also more relevant in Part 3 of the Ontario Building Code, which is the do I have them backwards, or the small buildings and houses, as opposed to the commercial space, which is a lot more prescriptive, or is a lot more performance based, and engineers and architects would be able to assess our system very easily. So that probably parks itself, but the ULC, UL aspect, the ratings for floors and ceilings and walls and so forth are really no different than it would have been for standard construction. But we definitely need to go through that process and build a building with somebody and then see what the locals say about it. What type of bolts are being used throughout the structure? Are structural connections able to be made entirely overhead, or is there a need to make connections from scaffolding and ladders and module interiors? I'll leave that to you, Julian.
Very good question. So you'll note that we're in this image really shows it clear. We're using these flanged fasteners throughout. So these are high strength bolts. They're commonly used in the automotive industry. If you next time you're on the highway, look over at the rails under a truck and you'll see these all over the place. They have serrations on the underside of the heads that provide tremendous locking action. It's pretty interesting when you torque these down. If you want to take something apart, reversing it requires a much larger force to get it moving backwards. And we've used those obviously to prevent accidental loosening. We also use those flanged heads because when you're joining quarter to quarter, the larger the area that you engage, and you can particularly see that in the top left and top right here. Top left is really very clear. You are improving the clamping action, and you're improving the overall fixity of the connection. So that's the type of fastener we're using. What was the second part of the question?
Do you have to, what types of fastener? Are structural connections able to be made entirely overhead, or is there a need to make connections from scaffolding, ladders, and module interiors?
Got it. So the connection. So we've facilitated multiple different ways of completing the connection. So number one is from the outside. So if the facades aren't on the building, it's dead easy to get at the connection. So the connections that you have to make. I wonder, do we have drawing tools in this? Can I use a drawing tool?
No, I don't think so.
So maybe you can see my cursor. It's this fastener here that is made that is installed at the point that the module is dropped. So the pin drops down through these twin rectangular openings, and it lies in next to this vertical plate, and you drive that bolt in. The bottom end of that pin is threaded, and that's what gives you your primary vertical connection. And you can access that connection through these obround openings. You can also install the match plate bolting through those same openings. So this connection can be accessed from the outside or from the inside. And so if you want to assemble the building from the inside, then you simply have to leave an access point either in the ceiling or in the floor that gives you access to this area. and there you go. So there, you know, it's definitely possible to do it either way.
And that's about stacking the building. When you're putting the module together, you're basically building the floor, building the walls, lying on the floor, and then lifting up the walls, attaching ceiling rim joists, and then all the ceiling ceiling joists. At that time, you're using some scaffolding or some ladders. We just used ladders. It was quite straightforward. It's only 10 feet up, and there you go. While this picture's on the screen, I think I want to point out something important. What Julian understands is the supply chain capabilities in this industry, and the precision is built in where it belongs. So the distance, for example, from that large bolt to the horizontal and vertical connectors is very precise, and that's what brings it all within a millimeter or less. But you'll see there's gaps between the horizontal rim joists and the column, and that's because, you know, manufacturing processes, laser, etc., aren't perfect, and we don't really care that that gap is there, and we also don't really care if that gap has got some tolerance, because that doesn't affect the performance of the overall system. So we're not measuring end to end on that beam. We're measuring how did the hole get in the right place with respect to the vertical connectors. Have you established costing budget numbers and project scheduling for comparison to traditional stick frame building? Well, do you want to answer that one, Julian?
Well, I can't believe anybody would ask a question like that. On to the next question, Blair. No, to not insult the caller. So the primary.
The caller has left, but I think it's worthwhile.
Okay. Yeah,
Go ahead.
I think, you know, if you're a true believer in modular construction, if you've drank the modular Kool-Aid, then the number one thing that you trust modular to deliver is schedule savings. So that was why, you know, Marriott, for instance, you know, the excellent work that Kareem Khalifa did to attract modular, to attract new modular builders to the cause of hotel construction, is all about advertising the schedule savings, the schedule certainty, and so on. And you know, we have, you know, at Walters Group, we created a facility to perform modular construction, and did a major scope on a multi-billion-dollar project in Calgary. And you know, we very definitely demonstrated the effectiveness of modular construction.
Well, actually, I'll comment on that. I was talking to a fellow on the West Coast. It was interesting, and he's doing wood modular from sort of 2 to 5 story, and he's been doing pretty well at it, busy. And he goes in and sees clients, and if they can't figure out what a day of savings in his schedule is, he doesn't do business with them. Now, I think that's a little bit of extreme, but that gives you a feeling for, you know, are you actually quantifying the ability to be faster? What is the projected timeline for exhaustive structural testing? This leads to our business model, and this is, you know, we know how to get that done. That's not hard to do. We know who to work with and all that. But what you're looking at is a couple guys with some cool ideas and a lot of connections. The way we go to business is we license our invention, and then on the backside sign up for a royalty stream. So therefore we need at this stage more licensees and or investors, frankly. We are more interested in the former, but you know, with the funding of a handful of investors and or licensees, we can go and get all those steps in place. At this stage, what you see is what you get, and we'd love to get these next steps. We spent our money on getting this stack, you know, getting this module system built, and we'd like to continue on with that. So,
I could add to that a little bit, is obviously having modeled the project in SolidWorks, we can move on to very, very useful or very, we can get very good results performing finite element analysis in the native analysis platform that's embodied within SOLIDWORKS and or exporting it to other platforms. We have, of course, done a whole bunch of engineering modeling prior to actually, making these first kits. That was the work that Intuitive did. But we do recognize the value of full-scale destructive testing. And I personally intend to build the rigs to perform that work and then perform it under the supervision of our engineers and possibly at one of these institutions that is interested in supporting our work. So I expect that work to be completed within approximately 6 months. But here's really what I wanted to say. That is that what happens as a result of that destructive testing is you're able to lighten up some of these connections to some degree. So, there will be savings in the amount of material that is used in various roles within the connection, but the fundamental concepts have been demonstrated to be sound. So, really, the change that results from that destructive testing is a 10 to 15% reduction in part weight. That's really so, and a change in cost that results from that as well. So that's the roadmap there.
I think we sort of hit this, but can you eliminate the diagonal bracing on the walls to allow for a larger opening? The answer is yes, and it really depends on the building. And yes, we chose to have all the bracing because we wanted all the modules to be the same, but we definitely would develop a bracing strategy for your building.
Yeah.
Do you have any details highlighting the connection to the foundation? Could you repeat the dimensions of 385 square feet unit? The dimensions of the system you see is 28.5 feet by 13.5 feet by 10 feet high. We have a number
of inside ceiling height.
Sorry?
Which gives you a 9-foot inside ceiling height.
Yeah, right. And as far as connections to the foundations, you want to comment on that?
Yeah, I can provide an image here. I will get that up on the screen in a second here. I was encouraged to keep the PowerPoint short. There's a bunch of things that we didn't show that we could have. So in the case of this particular project, the MSP, as we called it, the multi-story prototype, there's the connection to the foundation. So what you've got is a big concrete block. I think you saw that earlier. It's got a base plate sitting on top of it, and the base plate is supported by a stack of shims until the top face of the base plate is level. And projecting from the top face of that plate is an up-facing square tapered pin. And so the modules dropped on that. You can see they located here in the center very, very tightly. And then a bolt is driven through this vertical stiffener and into the side of the tapered pin. And we put a tapered shim, a tapered washer, basically beside that pin and the plate to ensure that there was full bearing. Not that it was realistic, not that there's any realistic significant strain on this, but more or less to demonstrate that. In a production situation, we've designed a foundation for this system. It would actually work with the pins facing down, as we have in all of the other levels in the structure, and we'd be happy to share that with anybody that is going to start designing a building around this system. We can share our foundation design. I should say foundation interface design, because that really is what that component is. It's a foundation interface.
Right. Have you considered modules intended for elevators and stair towers? You going to tell your joke there?
Yeah, I'm going to tell my joke. This joke is you know, it's like Monty Python, the funniest joke in the world. You know, this joke shouldn't be told because of the number of people that have laughed so hard they injured themselves. So while we have developed a spectacular system here, and it's you know, very, very nice, unfortunately we can't provide windows, doors, stairs, or elevators. So really you have to ship the modules with the people in them already. But we do believe there is a means to provide a feeding tube of some kind to keep the occupants of the building alive. So, you know, I'll just pause there for a second while everybody laughs themselves out. So certainly designing a modular stair tower, a modular elevator shaft, and so on is not challenging. We've achieved that. Walter's group, in fact, and myself together have done fundamentally modular stairs previously on projects like Bloomberg's headquarters in New York and the Ball in Calgary and so on. And certainly, you know, we're familiar with all the issues that, you know, that have to be dealt with there. You know, not at all challenging.
Okay, I think I had another detail on that, but we'll go. Possibility to combine with CLT. Why not? You could combine with all sorts of things. Our interface to all the rest of the building is industry standard. So if you wanted to build a podium on CLT and then hoist, you know, modules above it, great. But the members of our system are what you see in the design.
Yeah. Interestingly, one could contemplate a steel non-combustible stair towers and elevator shafts built with this system surrounded by CLT. And that, you know, because in many jurisdictions you need non-combustible construction for the, you know, for the means of egress. So
we answered this question about floor to ceiling. So the one you see here is 9 feet, but we could do whatever anybody wants. Do you have any experimental test on behavior of connection, like being stiff and ductile enough under lateral loads?
Sorry, one more time?
Do you have any experimental test on behavior of connection, like being stiff and ductile enough under lateral loads?
I think this may be a question related to seismic performance. So that's an example of the type of testing that we have to do. I brought this slide up, well, not necessarily testing, but development that we have to do. I brought this slide up. There are little you'll see little notches in the top and bottom flanges of the rim joist. They were put there for the purpose of locating to the backstops and the press brake, independent of the sheared edges of these parts. Those are cut features, but they resemble the ductility providing features that are part of a number of seismic moment connections. So that may be a path forward for us, is to provide some ductility in the vicinity of that shear connection, you know, is one route. Another route, of course, is reducing the stiffness of those connections and putting energy absorbing diagonals into the structure. So there's a bunch of paths to seismic behavior that you know, we will explore, we intend to explore. It's certainly on our roadmap, a seismic version of this system, a seismically compliant version of this system.
So the person who asked the question has a Hotmail account. I appreciate it if you reached out to me, Blair at VECTORMINIMA.com, and let me know who you are, and we'll be happy to engage your question. Thank you, a nice thank you from a gentleman who had to leave. Next one is, in a multi-story application, what would be the total build of a ceiling and floor cassette between floors? A build of a ceiling and floor cassette between floors.
They're talking about what is the finished floor, top of finished floor to underside of finished ceiling thickness, I think. That's what that question is.
Yeah, just the word cassette is a little confusing, but yes.
So it is
Oh, no, the question is total build of a ceiling and floor cassette between floors. This word of cassette is what's confusing. So if you took the underside of the ceiling and you went up to the next module's top side of the floor, what's that dimension?
Right, that's how I understood it.
Okay.
So it is 10 plus 3/4 plus 4 plus half, whatever that is.
Yeah, the gentleman corrected himself. Instead of cassette, he said build up. That now makes sense.
Yeah. So it's 10, 4, 1, and 0.5. So it's 14, 15, 15.5.
And then it
Which, by the way, in the modular industry is very thin.
It says it is deep enough to meet SB 10 requirements for unconditioned crawl space.
There is only so first of all, there's a 1/2 inch space between the underside of the 9.5 inch joists and the top of the 4 inch ceiling joists that is there for the installation of a sheet metal layer that is commonly provided in modules of this type to walk on during the assembly of the building, but which also divides that space that he's describing into a 10-inch portion and a 4-inch portion, if you're talking about the inside height. But yes, it's absolutely true that that space may be considered in some jurisdictions to be effectively a crawl space, in which case it has to be fire stopped every 3 or 4 modules or whatever it is, depending on the jurisdiction.
So then he replied that
there also must not be any combustible material in that void. And so consequently, it's got to be rock wool and steel, and that's it in there.
So the gentleman responded with that 15.5 buildup is very competitive for a modular system. So well done, Julian.
Thank you.
Well, that's the end of our questions. I really appreciate more than half of the people are still here. I know we're now 45 minutes afterwards, and so next time we'll schedule it for 2 hours. I'll ask you one more question, and you can tell me or not. You can also get a hold of one of us, Blair at FacadeSystemsInc.com, or Julian at the same, and you'll see email from us probably tomorrow or maybe today, announcing our offer for modules. We very much appreciate everybody's attendance at this. We very much appreciate you connecting to others of your colleagues that'd be interested in this. We're holding similar webinar, maybe with improved content based on what we learned today, a week from today and 2 weeks from today. And the registration links are on our website under virtual launch. And we will go through your questions, and any that are not on our Q&A on our website, we will add those to our website over the next couple days. 86% would like to hear about our offer, so that's really cool. Thank you very much. Well, it's very encouraging, you know, when you're an innovator and working with such an innovator like Julian. It can be lonely. It's hard work, and we really appreciate your support for what we're achieving here, and we hope that goes forward for your opportunities with your buildings and licenses and etc. So we're very eager to help you out in what you're doing, and we think there are very low barriers to entry to actually do that in short order. Julian, if you have any last words.
No, you've said it very well. I certainly appreciate everybody that attended today. Thank you for your interest, and we look forward to answering your many questions and engaging in discussions of how we deploy this on a broader scale around the world. I should mention we've had great telephone calls with people in the UK, in Singapore, in mainland China, in Korea, across the United States, Argentina, Mexico, Spain, South Africa, and that's just in the last 2 weeks. So, you know, the interest in what we're doing has spread rapidly, and it's gone viral globally. So we had the 7,000 views of my LinkedIn post, I think, had a lot to do with that. And anyone, by the way, who wants to communicate with the broader modular community, the hashtag modular seems to get a very, or hashtag modular construction ensures you a pretty wide audience, a very diverse audience.
So we'll wind it up there, and in a day or so, this recording will also be on our website. And I thank you. Very, very excellent. We really appreciate all the questions. We almost went twice the content by just based on your enthusiasm and your questions. So you have a great day, and thank you so much. Bye now.
Thank you, folks. Bye-bye.